Hi, everyone. My name is Alpana Gulab, and welcome to today's session. So today I want to dive into some concepts, some strategies, and best practices for designing a state-of-the-art cloud data warehousing solution. Now, when we talk about this state-of-the-art data warehouse, it needs to be able to handle thousands of concurrent users, needs to be providing the best performance and at the cheapest, most predictable costs. As most of us already know, Amazon Redshift is the petabyte scale data warehouse in AWS. And this is the service that I'm going to be diving into today. Now, before I get started, I want to run this session a little bit differently, so a little bit more interactively. And to help us along with that, I'm joined by my good friend, my fellow SA, Peter. Peter, who's going to help me to get my message across. Hi, Peter.
Howdy.
Okay, so Peter has been working with our customers for some time on things like cloud migrations, also re-architecting and modernization of customer workloads. So Peter, I'm hoping to hear from you to get us started with this around customer perspective. So what are we seeing in the data analytics and data warehousing space? And what are the new realities that customers are facing?
Cool. There is, in fact, a huge amount of change happening in the world of data analytics. For one, there is an exponential growth of event data. Data is now viewed as a strategic asset. Data is no longer something cumbersome to store and something expensive to maintain, but it's instead becoming part of companies' business models. Also, we see end-to-end insights from analyzing of data. Customers want real-time analysis and don't want to wait for data to be ingested. Traditional forms of data management is challenging to catalog and hard to analyze. On-premise data is often in silos. Building ETL can be complex and expensive. There's also a trend of large-scale migration to the cloud. Many benefits here, of course, without compromising security. Some data warehouses like Netezza announcing end of support. The question I often get asked, and I'll put it to you, is how do customers take steps to become data-driven companies?
Okay, so becoming a data-driven company, it speaks to getting the most value from your data. And the solution here is simply modernizing your data warehouse to enable you to turn data into insights. So breaking free from legacy databases, then moving to managed databases and building data-driven apps. And to gain insights, and talking about data warehousing in particular, we start off by modernizing our data warehouse. So I'd like to go over here. And what does data warehouse modernization actually mean? So the term data warehouse, it's not a new concept, but there are a lot of improvements that customers desire. For example, scaling your data warehouse. In a classic data warehouse, it could happen that we can't run a specific report because there isn't enough storage or enough processing power to do so. So these shouldn't be limiting factors. Then, of course, we have to talk about speed. Today, we want and need our data warehouse to be fast for multiple users. The data warehouse, it's no longer just no longer just accessible to one team or one analyst, for example. We should be able to scale with storage and with performance. If we consider this to be a time of web services, I would expect to be able to run a query or submit a request on a website as a user or as a customer, and it should be able to run a query on the data warehouse and give me results. So, we think of the scale of a school or a large organization or even a country's population to be able to run queries on a single data warehouse. Then with added features and functionality, at the end of the day, it needs to be something easy to use. So I mentioned that the data warehouse of today should ideally be accessible by more teams and more customers. It needs to be something more intuitive for business users. I shouldn't have to talk to a lot of people and to understand complex terminology to be able to benefit from the data warehouse. And one last important concept, when we talk about modernizing a data warehouse, it's the concept of data lakes. So data warehouses, they were and they are relational in nature, but data today, it's much more unstructured. So, we've got text, we've got videos, we've got images. So it doesn't make sense holding these in relational databases. And this is where the data lake comes into play. Now, how do we combine them? So say, for example, you've got a streaming service, using the data warehouse, and then we've got tweets or hashtags regarding the streams that are unstructured, stored in the data lake. we should be able to correlate the data in the data warehouse and the data lake to be able to deduce insights.
Cool. So we already know Amazon Redshift is the petabyte scale data warehouse offering from AWS. And some fun facts for our viewers. The Redshift service was actually launched in 2012, and it comes from the Amazon culture of innovation. So it was what customers told us they needed. And on the back of that, we brought the service to the market. Redshift changed the economics of data warehousing. There's no licensing costs. You only pay for what you use. And today, there are a lot of other cloud data warehouses to have launched. However, Redshift remains the most widely used, fastest, high scale, and lowest cost cloud data warehouses available. So my next question then is, can Redshift accomplish all of the above and modernize my data warehouse?
So yes and yes. We have tens of thousands of customers that collectively process over 2 exabytes of data every day with Redshift. And here's why. I talked about data lakes. So adopting a data lake-based architecture for your analytics will help you tap into your data. You can take advantage of data sharing, of real-time analytics, ML, AI use cases, all without re-architecture because Redshift is fully integrated with your data lake. Then transforming data, moving it into your data warehouse, it's not easy. And Redshift is the only cloud data warehouse that allows you to analyze any size of data in your S3 data lake without any ETL. Redshift also has the best performance. It is the world's fastest data warehouse with up to 3 times better performance than other cloud data warehouses. And it keeps getting faster. In fact, we have Redshift offerings that today are 10 times faster than what was 2 years ago. Another reason why Redshift should be the data warehouse of choice is that it offers the best value. So when it comes to pricing, we are talking about predictable costs. It's usage-based pricing instead of license-based pricing, so that you can get started very easily. We've had customers start small, so at just 25 cents per hour, you can scale up to 1 terabyte for under 1,000 terabytes a year. $1,000 per terabyte per year. And then with reserved instance pricing. So this pricing model you can use, and you can save 75% compared to on-demand pricing. Then there's another major benefit around pricing. Unlike other data warehouses where you need premium versions for additional enterprise capabilities, Redshift's pricing includes built-in security, includes data compression, backup storage, and data transfer. Then we talk about scaling. So clusters can scale from 160 GB to 2 petabytes of storage. So resizing is completely managed by AWS, and there's no limit to how often or how much your cluster can scale. You can also scale to exabytes of data with your S3 data lake by querying it directly without needing to load it into the data warehouse. Then security, always our number one priority at AWS, and of course for Redshift. Redshift, like all of our services, includes the comprehensive range of AWS security services at no extra cost. Finally, Redshift is simple to set up and operate, and most administrative tasks are automated. It automatically performs maintenance tasks like vacuum, like analyze and optimizes queries. And with Redshift Advisor, you will receive prompts to make changes to continue to optimize your workloads.
Cool. So you've given us quite an idea of what we can do with Redshift and why Redshift should be the data warehouse of choice. So could we see it? Could we launch a cluster and build ourselves a state-of-the-art data warehouse in the cloud?
Yes, of course. Yes, of course. So, okay. So what I want to do now, I want to walk through a really quick process on how to create and how to launch an Amazon Redshift cluster. Then we're going to add a sample data set, and Redshift will load the sample data set, and then we'll connect to the cluster using the query editor. Okay, so let's have a look here at the AWS console. So just some prerequisites to launching your cluster. It's very simple, very basic. You just need an AWS account, which you can very easily create. And you also just need to be aware of your company's firewall rules. Like any database that you may need to communicate with, we need to communicate with it via an open or available port. Okay, so let's have a look at the console. This is the AWS Management Console front page. And so we've signed into the console. And then to get to the Redshift management page, we can either type in Redshift here in the search page, but I've already got it here in recently visited. Okay, so then this is the Redshift welcome page. And here we're going to click on create cluster. Okay, so there's a couple of configurations here, nothing too complicated. Okay, so in the first part, we've got the cluster configuration, and we have to set the cluster identifier. So this is just the unique name or unique key that's going to identify the cluster. Then the question is, what are you planning to use this cluster for? So there is a free trial option here. And it depends on if you've ever used Redshift before. I think there's a 2 to 3 months of using a specific instance node type for free. But I'm going to go with production because I want to show you the different options. Then the next option is to choose the size of the cluster. So here there's a help me choose option. And what happens here is you can use this option, and it's based on things like, your estimated storage space, how many months of data it contains, and how much of data that you want to query at a time. So I'm going to go with I choose, and we'll choose the node type that is a DC2 node type, and we'll go with the DC2 large. It's the smallest instance that's available. The number of nodes, as we said, in this case, can go up to 1 to 32. Let's make it 3 nodes. Okay, there's a little configuration summary there that shows the estimated on-demand compute price. Okay, and then with the sample data, I'm just going to click load sample data here. And what that does is it's going to include a sample data set with a sample database, and we're going to do some querying there. Then there's the database configuration. All we set in here is the username and password. And the cluster permission. So this is if you want to access other AWS services, you need to grant Redshift permission. So to do that, you associate IAM roles to this, but we'll do this a little bit later. Then in the additional configurations section, these are things like your VPC. You can set your subnet, preferably your private subnet, and you can set or change your port, which is 5439 by default for Redshift. So we'll leave all of this as is, and we'll simply click on Create Cluster. So generally, this takes less than a minute in my experience, but let's just say 4 to 5 minutes just to be safe. Okay, so I want to just go back and make sure that there's a proper understanding of what we did and some of the configuration options that we went with. So as a reminder, Redshift started out as a Postgres fork, but we completely rewrote the storage engine to be columnar. We made it an OLTP relational database store by adding analytics functions, and we also made it massively parallel processing system so that it can scale. We have preserved capabilities with Postgres, which is why you could actually use a Postgres driver to connect to Redshift. But it's important to note that Redshift is an OLAP relational database. It's not an OLTP relational database like Postgres. We then leveraged and integrated Amazon Redshift with other AWS services in the AWS ecosystem, so things like your VPCs, KMS and IAM for security, S3 for data lake integration and backups, and of course, CloudWatch for monitoring. All of this together makes up the service that we know as Redshift. Okay, let's now take a closer look at the Redshift architecture. So you can connect to a Redshift cluster with both JDBC or ODBC drivers. And since it was forked off Postgres, you can make use of open source Postgres drivers as well. There's the part of the cluster that the user connects to and works with. This is what we call the leader node. So the leader node is required and automatically provisioned in every Redshift cluster. But customers are not charged for the leader node. The leader node is responsible for being the user's JDBC or ODBC entry point to the cluster. It's storing metadata. It does query compilation and optimization and caching of result sets. Then there's the compute nodes. So 3 nodes in our case. These are responsible for the actual query execution and data manipulation. And because Redshift employs a shared nothing architecture, compute nodes operate in parallel. On a larger node type, you can have up to 128 nodes. Lastly, there is interaction with S3. So loading and unloading of data, for example, also backups and restores. All of it running in the background. Finally, one of the features or characteristics when we talk about the state-of-the-art data warehouse is Redshift Spectrum. So with Spectrum, you can query data that is residing in S3 without having to load the data into Redshift tables. What you're pretty much doing here is extending your data warehouse to exabytes of data in your S3 data lake.
Cool, thanks, Alpana. I'm familiar with Redshift Spectrum in theory. I've read that it actually resides on its own dedicated servers, which are independent of your cluster. So what it does is it pushes compute-intensive tasks down to the Redshift Spectrum layer. So these queries use much less of your cluster's processing capacity than other queries. Redshift Spectrum also scales intelligently and also takes advantage of massive parallel processing. Would you be able to show us how it works now?
Yes, sure. So our cluster should be up and running now. Let's have a look. Okay, so what I want to do now, let's query our cluster. Remember, we included some sample data in there, and then I'll show you how to get started with Redshift Spectrum. Okay, so let's have a look. And our cluster is in the status here. It shows that it is available, so it is up and running. Okay, so to query this database, there are different ways that we can connect that we talked about, but the easiest way is just to open up our query editor here on the left-hand side. And then we're going to connect to the database. So the connect to database button here, and we can create a new connection. Okay, I seem to have lost it. We can create a new connection, and there's our cluster name. Our database name is div, and our user is the AWS user. Okay, so we can connect to our database and have a look at this public schema, and here is a list of the tables that we loaded as our sample data. So there's the event table, and there's the table definition. We can run, simple commands like just select account star from event. Run, we click the run button and just give it a few seconds. And there's our query results. Query 59 ran. It ran in 0.3 seconds, and the count of the number of rows there is 8798. So we can run different types of queries here. Just to give you an example, I'll just copy and paste some from our documentation. Here's something that you can find the total sales on a given calendar. So we run that query. Also just give it a few seconds. And the query results there. Here's another one, for example, find the top 10 buyers by quantity. So just basic SQL queries that you can run directly from the query editor directly onto the Redshift cluster. So again, just give it a few seconds, and there's our query results of the top 10 buyers. So you can, of course, load your own data, using the copy command. But I want to show you how easy it is to take advantage now of the features of Redshift. So we spoke about Redshift Spectrum, which you can use to query data in Amazon S3 files without having to load data. Okay, let me show you how to get that going. So we have our cluster, and we have an S3 bucket. Say it's called AWS Sample Database. Now we need to allow Redshift to access the S3 service or the S3 bucket. Then we'll create the external schema. Then we'll create the external table, which references the data in that bucket. So first, to allow Redshift access to S3, we can do this by associating it with an IAM role. So if you remember earlier, when we created the cluster, there was an option to do that. But we can also just go back to the cluster now and edit it, and I'll show you how. So back to our main page, we can select the cluster, and under Actions, we can manage IAM roles. So we have a role here that I created called My Spectrum role. All we'll do is associate the IAM role and save changes. Okay, so all external tables must be created in an external schema. The external schema, it references a database in the external data catalog. And this can be Athena data catalog, or it could be a Glue data catalog. So we're going to create an external database in the Amazon Athena data catalog. Okay, so to do this, again, we'll head to our query editor and just make sure we're still connected. And then we'll just run a create schema command. And what that looks like. Okay, so we're going to create the external database in the Amazon Athena data catalog. And to do that, we will just run a create command. So create external schema, it's called Spectrum, and we're going to reference the IAM role that we just added. Okay, we click on run, and we'll just give it a few seconds to create that schema. And once we have that, we'll create the external table. To do that, again, we'll just run a simple create table command. It looks something like this. So create external table. The table is called sales. And it's referencing the location in S3. And there's our bucket over there. So again, just click run and give it a couple of seconds to complete. Okay, so with the external table created, we can query it now using the same select statements that you would use to query any other Redshift tables. So for example, just select count star from the same table that we just created. Okay, and give that a couple of seconds to run. So remember we spoke about the event table in our database. So we can now run a join command with the external table, the Spectrum sales table, with the local table called event. So something like this. Okay, that's our join command. And again, just click on run and give it a couple of seconds there to complete. Okay, and there is the result set. So this is the result from joining the table on our data warehouse with a table running in S3. So let me show you something that's also pretty cool. The query plan we can have a look at. So we can click here on query 203 to look at the details around that, or we can go here to view all the queries that was run on our Redshift clusters. So here is our join command. So we can open that up. And if we look closely at the query plan, we can see that it is running here, for example, S3 query plan, query scan of sales table. That shows us that it's scanning the S3 table. So yeah, that was almost too easy.
That was awesome. Thanks so much, Alpana. That was very cool. So one of the biggest challenges I've seen with customers is managing that substantial amount of additional data. There's a constant trade-off between what data to load into the data warehouse, what data to archive into storage. It has to do with managing costs and keeping the ETL complexity low. I can see with Redshift Spectrum, it makes it easy to analyze large amounts of data in its native format without requiring you to load the data. But of course, Redshift as a data warehouse is scalable, right? How easy is it to scale a Redshift cluster? Because we obviously need to make sure we minimize any downtime to the business, right?
Yes, absolutely. To increase query performance or to increase CPU or memory, you can very easily increase the number of nodes in the cluster. And there are two options around this. So there's the classic resize option. This is the older option that's required. It requires that the cluster goes into a read-only mode. And depending on the size of the cluster, this could be for an hour or up to a few days. And this is because the way it works is it provisions a new cluster while copying data over from your source cluster. It then distributes the data to the new nodes according to the distribution style, and it runs the analyze command. Then there's the elastic resize option. So this is the recommended option. It requires less time. It does not, however, it does not sort tables or it does not reclaim disk space. So it takes about 10 to 15 minutes, during which time that the cluster is in read-only mode. There are some sizing specifications or limitations with the elastic resize, in that you can only change to certain instance types, and that the number of nodes that you can change to, I think it would be either double or half. Let me show you what I mean here. Okay, so this is, back to our dashboard here, and we've got our Redshift cluster. If you can just click on that and open that up. If we want to scale it, we'll simply go to Actions, and we'll go to Resize. So as I said, two options, elastic resize and classic resize. We're currently using the DC2 large, so there are a few options here that we can change to. We'll leave it at the DC2 large. We're currently running 3 nodes, so we can only increase it to double of that, which is 6 nodes. There's the option to resize the cluster now, or you can schedule it at a later time. And that's that. We can click Resize Cluster Now. And this process, it takes about 10 to 15 minutes, and we should then have a cluster of 6 nodes.
Cool. You mentioned different instance types or node types. How would I decide which one to use?
Sure. So there are 3 types of nodes. Let me show you from the Create page that we looked at earlier. So if we have a look here, there is, we'll start at the bottom. There's the DS2 nodes. These are the legacy nodes. So they make use of hard disk drives, and we actually recommend using RA3 nodes instead. So if you're using 8 or more DS2 nodes, we'd recommend rather that you upgrade to RA3, and you'd get 2 times more storage, and you'll get better performance for the same on-demand cost. Then there's also DC2 nodes, the one that we launched now. So DC2 nodes, they have local SSD storage included. So data is stored locally for high performance. For data sets under 1 terabyte, we recommend DC2 node types. And if you expect your data to grow, then we'd recommend using RA3 nodes, so you can size compute and storage independently. So that's the RA3 node. They have managed storage, and you can scale and pay for compute and storage independently. So the managed storage, these are high performance SSDs. And when the data of a node grows beyond the size of the local SSDs, managed storage automatically offloads that data into Amazon S3. And also just keep in mind that all 3 of these node types, you would choose the size and the number of nodes based on your performance requirements. And of course, you'll only pay for what you use.
On the topic, good segue to pricing. The pricing structure, how does Redshift offer the best value compared to other cloud providers?
So with all 3 of these node types that we had a look at, there is a on-demand pricing structure. So you'd pay for capacity by the hour with no commitments and no upfront costs. You'll simply pay an hourly rate based on the type and number of nodes in your cluster. There's also this pause and resume feature that I'm not sure you've heard about. It allows you to suspend on-demand billing during the time that the cluster is paused. Then there's also something called reserved instances. So with reserved instances, you can benefit from significant savings over on-demand by committing to use Redshift for a 1 to 3 year term. And there's 3 options here. There's no upfront, where you'd pay nothing upfront and you'd commit to paying monthly. There's partial upfront, you'll pay a portion, and then the remainder over the rest of the term. And of course, there's all upfront, where you'd pay the entire reserved instance term in one upfront payment.
Cool. So we covered Redshift Spectrum and connecting to the data lake. We looked at how Redshift is the most scalable, the best value with predictable pricing models. Now, what about security? We all know security is the #1 priority at AWS, and also a huge concern for my customers. So how does Amazon Redshift keep our data secure?
So first, Redshift, like all of our AWS services, it benefits from the AWS security building blocks. Being part of the AWS ecosystem means that Redshift as a service integrates with, AWS IAM, for example, Amazon VPC, also AWS KMS, which is our key management system, to protect data in transit or at rest.
You mentioned IAM, Identity and Access Management. So that reminds me, does Redshift support single sign-on?
Yes. So if you want to use your corporate identity providers, whether it's Azure Active Directory, whether it's Active Directory Federation Services, or any other SAML compliant identity providers, you can configure Redshift to provide single sign-on.
Cool. Oh, and what about MFA then as well?
Yep. Yes. So you can use multi-factor authentication for additional security when you're authenticating.
Okay, no, that's awesome. Just one other thing, can you access those compute nodes directly?
So no, this is not possible. Compute nodes are in a private network space. It can only be accessed from your data warehouse cluster's leader node. And if you think about it, this provides an additional layer of security for your data.
Okay, got it. Just one last question on the topic of security. How granular can you go with access controls? Can you have column level security?
Yes, you can. You can have column level security. You can set it up so that users would see only the data that they should have access to. And you can do this by granting or revoking column level privileges to a user or to a user group.
Cool. So now that we've covered the security aspect, just one more challenge.
Yeah.
What does Redshift do just in terms of kind of improving performance management sort of things?
Okay, so when it comes to improving performance, there's of course a number of things that we can look at. Right sizing instance nodes for one, running a vacuum or analyzing your data. We can also look at tuning queries, for example. But there's the other option. It's Redshift workload management feature. So WLM that allows for the separation of different query workloads. So your goals here, they are to either prioritize important queries, for example, or to throttle less important queries. You can also use it to divide up cluster memory or to set query timeouts for long-running queries. So by default, Redshift enables automatic WLM, and this is done through parameter groups. The default parameter group has automatic workload management enabled, and we can create a parameter group for manual workload management. And with automatic workload management, what happens there is Redshift determines the amount of resources that queries need and adjusts the concurrency based on the workload. Of course, in contrast, manual workload management requires you to then specify values for query concurrency and for memory allocation. One more thing that I want to add here, workload management also has an option for SQA, which is short query acceleration. And what happens here is short running or lightweight queries, they can complete even while long running queries are active. But Redshift has many options for improving performance. I mean, we can talk for hours on how to use workload management, also making use of concurrency scaling. There's data distribution as well and keys, compression as well of data, which decreases I/O, which we can all read about.
Awesome. Speaking of data, given that it is so important and it's a strategic asset, I noticed when we created the cluster, I didn't see an option for backups or backup scheduling.
Right.
Can you maybe talk to backups briefly, Alpana?
Yeah. So this is something that's super special about Redshift. It replicates all of your data within your data warehouse cluster when it's loaded, and also continuously backs up your data to S3. What this means is that there are at least 3 copies of your data. So there's the original and the replica on the compute nodes and a backup in Amazon S3. You can also configure it for DR, so you can replicate your snapshots to S3 in a different region. When you need to restore a backup, you have access to all the automated backups within your retention window. And once you choose a backup to restore, we'll then provision the new data warehouse cluster and restore your data into it. I can show you quickly how easy this is. Okay. We can also just take a look at our resize that we kicked off earlier. Okay, back to the dashboard. And we can have a look here at our Redshift cluster 1. And as you can see, we're looking at 6 nodes that we resized earlier. So when we're talking about backups and restores, okay, there's already one automated snapshot here. Click on the one to open up that screen. It was taken today. It was taken just now. So to be able to restore it, we'll just select it and restore from snapshot. And we'll get some similar configuration options that we get in the create screen. So we'll give it a name. The node type size, the number of nodes again, database configurations, and we click on the restore option.
Neat.
Yep.
So you mentioned the automated backups, and you're restoring now. What would happen if I delete my data warehouse cluster to those backups?
Yeah, so automated snapshots are deleted along with the data warehouse when you delete the data warehouse. But you also have the ability to specify whether a final snapshot is created upon deletion. So it enables a restore of the deleted data warehouse cluster at any stage. And I think I can show it to you here. We just select the cluster. Very easily, we can click actions and we can click on delete. And there's the option to create a final snapshot that you can tick up and delete cluster.
Cool. Yeah, I think that's a nice bit of extra protection. So now that I have a pretty good understanding of Redshift, and I hear you, I think it's pretty amazing service. To take advantage of it, what's next? How would I migrate?
I'm glad you asked that question, and I am prepared for that question. So I actually have some slides on this topic. So, when we talk about the customer migration journey, the first step for migration is always the most challenging. Sometimes we find that organizations can get paralyzed. They can't figure out how to move every last workload. But there's no need to be overwhelmed. An iterative approach, it's almost always the right one. We often work with organizations to do a portfolio analysis to assess each application and then build a plan for what to move, in the short term, the medium term, and the long term. And beyond that, the AWS ecosystem is broad and deep. It includes tools and technologies to cover, nearly any solution that you want. We've designed AWS Database Migration Service, that's DMS, to be simple. You can get started in less than 10 minutes. Then there's also the AWS Schema Conversion Tool, which converts your commercial database or your data warehouse schemas to open source engines or AWS native services such as Aurora or Redshift. And I think that the real power of the solution becomes apparent when you realize that you can move between database engines and between data warehouses and move away from expensive commercial databases, to cloud native to open source solutions. And don't worry, at AWS, we don't believe in vendor lock-in. So you can use DMS just as easily to move data out of the cloud as you do into it. And I think that is a good place to round up. So thank you so much for your help today, Peter. I really hope that I've answered all of your questions and that we can conclude that Amazon Redshift is in fact your state-of-the-art cloud data warehouse solution.
Wonderful. Thank you so much, everyone, for your time. I hope the session was informative. I certainly learned a lot. Please remember to fill out the survey at the end of the session, and Alpana and I will stay online now to answer any questions you may have.
Thank you. Bye.
Thanks so much.